Today, my talk is on novel process for the manufacturing of trehalose, which is a high-value rare sugar. Before starting, I would like to thank this Venture Center team for making all these slides readable and understandable to all. So, trehalose is a high-value sugar. Please go to next. So, trehalose basically it is comprised of two glucose molecules which are joined with alpha 1,1 bond. It is a high value molecule in three industries: food industry, pharmaceutical industry, and cosmetic industry. In food industry, it is desirable because it reduces freezing point of food products, which prevents formation of ice crystals, and also it prevents proteins and other molecules which are supposed to damaged by freeze thaw method. This trehalose is highly stable in a wide range of pH. Therefore, it can be used in wide range of food products. It prevents start aging. It has water retention capability, and these features make actually extends the shelf life of food products. So not only this, trehalose also maintains the polyphenolic content, and thus it maintains the antioxidant property of the food product. It is a low cariogenic sugar. It has less sweetness. So when you are adding trehalose for all the aforementioned qualities, you are not adding too much sweetness that your food product may lose its flavor and quality. So your flavor and quality could be maintained. And according to several studies, if you intake trehalose daily, about 10 gram, it improves your glucose tolerance and mitigates insulin resistance. So it means the shelf life, the your lifestyle related metabolic disorders like obesity can be controlled if you are doing intake of trehalose. In pharmaceutical industry, because this trehalose molecule has capability to stabilize cell membrane and proteins, so it can be used as a cryoprotectant. So basically, it is being used as a cryoprotectant agent for protecting our sperm cells, blood cells, human organs for transplantation. It is also useful in cosmetic industry because it is having a moisture retaining capability. So because it retains moisture, so it is a very high value molecule for cosmetic industry also, and it also reduces body odors by degrading the short chain fatty acids. So for that, cosmetic industry also like to use trehalose in their products like moisturizer and other creams and shampoo. But mostly this trehalose is produced from maltose, and it is enzymatic conversion. But the major drawback for industrial production of trehalose is poor thermal stability of enzyme and low product yield. Can you please go to next slide?
Dr. Singh, can you move your mic a little closer to your mouth? There's a mic.
Okay. Now,
Okay.
is it fine?
Yeah, go ahead.
So we have a great market opportunity also because it offers several healthy options in food and beverages industry. I explained previously that it avoids ice crystal formation, and also it extends the shelf life, maintains the flavors. So because of several health benefits, it is a desirable molecule in not only in food industry but also in meat industry because it protects protein denaturation. So it also gives a good option for creams and shampoo for as a moisture retaining agent. So it has a big market, and according to CAGR report, by 2029, the market size of trehalose could reach up to 330 million. The price is approximately rupees 1,000 per kg, which depends upon which may vary according to quality and purity of the molecule. The major global manufacturer is Haishibara, but unfortunately there is no manufacturer in India. Please go to next. So who can be interested? The frozen food product industry can be interested because we offer a technology, so no import is required. Ingredient has a very good performance. It gives several benefits to your food products. Pharmaceutical industry may be very much interested because we are making it enzymatically, so bioproducts can be avoided. No contaminations can be avoided, and the trehalose can be used as a cryoprotectant agent in pharmaceutical industry, and also in cosmetic industry. It can be used as a moisture retaining agent. Please go to next. So this is what about the technology. We offer a technology which is based on trehalose synthase. a novel trehalose synthase variant that can transform maltose. Maltose contains two glucose molecule where two glucose molecules are connected with alpha 1,4 bond. So this trehalosynthase enzyme, it hydrolyzes maltose and reconnects those two glucose molecules by alpha 1,1 bond, and now it is trehalose. So this trehalosynthase basically is very stable enzyme. So because it uses a low cost sugar maltose, so your raw material is of low cost. Trehalosynthase is a very highly stable enzyme. We offer a very stable enzyme variant. So we could achieve about more than 70% conversion from maltose to trehalose. And right side, this blue box represents a flow chart, and this flow chart represents how trehalose can be made. For example, for the first, you have to express this trehalosynthase in bacterial cells. So you have to produce the enzyme in bacterial cells. Then the enzyme need to be extracted and purified, and then enzymatic reaction will be performed with maltose. So maltose will be converted into trehalose. About 70% conversion or more than 70% conversion we have achieved with our trehalosynthase variant, and this trehalose then can be purified by using industry economical method, chromatographic method, simulated moving bed chromatography, or separation purification of trehalose. Please go to next. Now, this slide actually compares the high Shibari technology, which is commercialized. They make trehalose, and it is commercially available, versus our CIAB technology. So this high Shibari basically they uses three enzyme variants obtained from three microbial sources, which functions at different temperature. Like for example, 5 degrees Celsius, 20 degrees Celsius, 40 degrees Celsius. But CIB offers one trehalosynthase variant that can function in a wide range of temperature from 5 degrees Celsius, 20 degrees Celsius, 30 degrees Celsius to 45 degrees Celsius. And it is a it makes trehalose with higher efficiency. For example, you can see the first one, Camelobacter trehalosynthase achieves 80% conversion at 5 degrees Celsius in 48 hours, whereas in our case we could achieve about 74% conversion in 12 hours. Likewise, in 15 minutes, about 60% conversion could be achieved. Likewise, and at 30 degrees Celsius, about 70% conversion could be achieved in 3 hours. So we are more, our enzyme is very highly efficient, and not only efficient but also stable. Also, if you compare the thermal stability, our enzyme is highly stable. An exposure of about 96 hours also retains 50% of its activity at 60 degrees Celsius. So it is highly stable enzyme. Please go to next. And if your enzyme is highly stable, you are offering economical method of enzymatic production of your molecule. Currently, we have demonstrated this technology at lab scale, maybe 1 liter. Sample is available, anyone can take. Patent is filed. So application approval is still pending at Indian Patent Office, which takes time. This has been published in a very reputed journal of American Society of Microbiology. Next. Yeah. So next step is we are looking for an industrial partner uh, that could be interested for technology licensing. We can work with digital partner for advancement and upscale of this invention. We can together work with industrial partner for writing a project, also collaborative project for translation of this invention at industrial scale. So anything we are open after a discussion with the industry, because our interest is that the invention which we have done in laboratory should reach to the society. Please go to next. Okay, this is our lab's portfolio. I work at CIAB. We have a team. We have made several inventions which are many of them are granted from Indian Patent Office. Many are pending. We have made several publications. We have well-equipped laboratory. Our contribution to science has been recognized by National Academy of Agricultural Sciences, National Academy of Sciences. These are two very important academies of India. Then Indian Science Congress Association has conferred Hiralal Chakrabarti Award, looking to our contribution to science. Then CRIST is a very reputed society that has conferred Gandhian Young Technological Innovation Award to our team for our work in rare sugars. So this is the whole portfolio of our laboratory. Please go to next. Thanks to Ms. Prithandya. She is very kind to making all these slides understandable to you all. Anyone can contact Ms. Prithandya about this technology. Thank you very much.